transmission until the current transmission is over.
Let's start. आप कर रहे हैं आप यहीं क्या आप रहे हैं अस्सलाम वालेकुम shall begin. So technical session 4 now is going to start. So first presenter is Mohammad Shuaib. He will be presented topic. His topic is which simulator to choose for next generation wireless networks simulation NS3 OMNET++. So now we start.
Bismillahirrahmanirrahim. Assalamu alaikum everyone. My name is Muhammad Akbar Kiani. I'm doing electrical engineering bachelor's from Maypur University of Science and Technology. I am currently in my final semester. I am here to present my paper, which is which simulator to choose for next generation wireless network simulations, NS3 or OMNET++. Before getting into the paper, let me introduce the author of this study. Our team consists of Dr. Sohaib Manzoor, Hira Manzoor, Mehak Manzoor, Dore Adan, and myself, Muhammad Akbar Kiani. As you all know, network simulations play a crucial role in studying the behavior of computer networks and communication systems. They provide us flexibility, repeatability, stability, and scalability in the experimentations. In today's market, there are a lot of simulating software present, out of which some of standing out are NS2, NS3, and OMNET++. But the question arises, why do even we use simulators in the first place? There are many reasons which may be pros in the cons, but the reasons are compelling. Let me introduce the pros of the simulators. They offer high reproducibility, they have lower complexity, and they are more cost efficient. As you can see from the graph as well, that when we move from simulation to emulation and emulation to test bed, the time complexity increases, same as our cost also increases. So and that's why we used simulators. In this paper we are basically comparing the two simulating softwares, which are NS3 and OMNET++. NS3 has a modular type structure written in C++ with a Python scripting interface which supports software integration and provides a real-time simulation environment. On the other hand, OMNET++ is a modular, extensible, and component-based C++ library with the graphical interface support, allowing the simulation kernel to embed easily into the user applications. So if we move into the performance evaluation section, before going to that, let me show you the network interface module of the both OMNET and NS3. OMNET have 4 layers: connection layer, management layer, MAC layer, and physical layer. Similarly, if we talk about NS3 NIC module, it have also 4 layers: connection layer, management layer, MAC layer, and physical layer. In today's paper, we have experimentized on MAC layer protocol, which is DCF, distributed coordination function, which is a MAC layer protocol, and we have run the dice model, theoretical dice model, on these two simulation softwares. So in order to evaluate the dice theoretical model in NS3 and OMNET++, the network is first loaded with the unsaturated to saturated condition by changing the traffic arrival rate, varying the number of nodes, window sizes, and cutoff phases. So in first phase, we have basically compared two modes, that is basic versus RTS CTS mode. In basic mode, which is basically a two-way handshake where the nodes transmit the packets after waiting a duration. If it senses the channel is idle, otherwise it start back off process by choosing the back of window size. And in RTS CTS scan, it is a four-way handshake where the node first sends the RTS frame to the reserve channel. After RTS frame is successfully received by the destination, it will send a CTS frame to all nodes so that other nodes pause their transmission until the current transmission is over. So you can see from the graph which is the result of this basic versus RTS scan modes. The upper line indicates the basic mode, while the lower dotted line indicates the RTS CTS scan. And you can see that both of the both of the software show very same results. So there's not much difference in this phase. In second phase, we have compared ad hoc versus infrastructure. In ad hoc, the network consists of devices that communicate directly with each other without any centralized thing. Like they can talk to each other without any centralized center. While in the infrastructure mode, there is a centralized thing which to which the devices are connected, and they can communicate with each other through it. So you can see from the graph that uh, they are showing same results, just a minor up and down, but mostly the results are same. So we can predict from this that NS3 and Omnet have almost shows almost same results. So we can use both of them in our experimentation, and we will get good results. uh, so at the end we can just conclude that we have performed a competitive study of a unified IEEE 802.11 TCF analytical model against the IEEE 802.11 max simulation model in our experimentation simulators. And the comparison is validated by varying system parameters such as number of nodes, window size, we can cut off phases, and packet loads in the we have basic access and RTs of a unified mode, and switching the network from unsaturated almost against the IEEE. So both of them shows similar results. So we can use both of them. Comparison is validated by varying system parameters such as number of nodes. Thanks for listening. Window side. If you have any questions, I'm open for the questions. Basic access and RTs. If you have any and switching the network from unsaturated almost against the IEEE. At first, both of them shows similar results. So we can use both of them. Comparison is validated by varying system parameters such as number of thanks for listening. Windows side. If you have any questions,
If anybody has a question, you can email to him. So now we move to next presenter. Next presenter name is Shoaib Manzoor, and his research topic is rare earth iron dope zinc oxide as a viable photoanode material for dye-synthesized solar cells. If anybody has a question, you can email to him. So now we move to next presenter. Next presenter name is Shoaib Manzoor, and his research
Sir,
topic is
please wait for a
rare
minute.
earth iron
Mr.
dope
Shoaib Manzoor
zinc
has
oxide
also
as a
sent
viable
us a video recording
photoanode
of his
material
presentation.
for
I'm going
dye-synthesized
to
solar cells.
now run that.
If anybody has a question, you can email to him. So now we move to next presenter. Next presenter name is Shoaib Manzoor, and his research
Sir,
topic is
please wait for a
rare
minute.
earth iron
Mr.
dope
Shoaib Manzoor
zinc
has
oxide
also
as a
sent
viable
us a video recording
photoanode
of his
material
presentation.
for
I'm going
dye-synthesized
to
solar cells.
now run that.
If anybody has a question, you can email to him. So now we move to next presenter. Next presenter name is Shoaib Manzoor, and his research
Sir,
topic is
please wait for a
rare
minute.
earth iron
Mr.
dope
Shoaib Manzoor
zinc
has
oxide
also
as a
sent us
viable
a video recording
photoanode
of his
material
presentation.
for
I'm going
dye-synthesized
to
solar cells.
now run that.
If anybody has a question, you can email to him. So now we move to next presenter. Next presenter name is Shoaib Manzoor, and his research
Sir,
topic is
please wait for a
rare
minute.
earth iron
Mr.
dope
Shoaib Manzoor
zinc
has
oxide
also
as a
sent
viable
us a video recording
photoanode
of his
material
presentation.
for
I'm going
dye-synthesized
to
solar cells.
now run that.
If anybody has a question, you can email to him. So now we move to next presenter.
So please wait for a minute. Mr. Shoaib Manzoor has also sent us a video recording of his presentation. I'm going to anybody has questions, please raise your hand. Now we go to the next presenter. So please wait for a minute. Mr. Shoaib Manzoor has also sent us a video recording of his presentation.
I would request you to ask Ms. Albab Robinson to start her presentation. This is ID number 31, ISO Comparative Analysis of
Wait for a minute. Mr. Shoaib Manzoor has sent us a video recording of his presentation.
Machine Learning and Deep Learning. Ask Ms. Albab Robinson.
Thank you. Thanks, Mr. Irbad. Here's a start the presentation. Now you can. Are you available now?
Wait for a minute. Mr. Shoaib Manzoor has sent us a video recording of his
Thank you. Thanks, Mr. Irbad. Here's a start the presentation. Now you can. Are you available now?
wait for a minute. Mr. Shoaib Manzoor has sent us a video recording of his
You can open it. Thanks, Mr. Irbad. Here's a start the presentation. Now you can. Are you available now?
layers to automatically learn intricate patterns and representations from data. To evaluate our dataset, we use CNN, RNN, and LTSM. LTSM is a type of RNN and also transformers. CNN models, CNN-based models are trained to identify patterns in text. RNN models consider text as a sequence of words. The types of RNN that we used are simple RNN and long short-term memory (LTSM). Transformers are a type of deep learning. Uh, Deep learning. They are self attention mechanism to capture. They use self attention mechanism to capture contextual relationship between words in a text, allowing them to understand the meaning and the context of word within a sentence. To evaluate our dataset, we used BERT transformer. BERT is a pre-trained model that is trained on a huge data set. So to obtain best results, we used two versions of our data set. One was original data set that was in Sindhi, and other we translated using Google Translate. These are the results of our machine learning algorithms. The highlighted numbers shows the best performing algorithms in terms of precision, recall, F1 score, and accuracy. The results are further explained in comment section. The analysis of previous results, neural network was the best performing algorithm with both feature extractors due to its ability to learn complex patterns in data. SVM logistic regression stands next with both feature extractors and extraction methods giving all over high performance across all evaluation matrices, benefiting from their ability to handle linear separability and noisy data and sparse representation. All other algorithms performed relatively similar except KNN. KNN, we used the K value which was equals to 5. If we tried to go higher, the risk of data smoothing and computational cost increased. If we went lower, the result even decreases. These are the results of deep learning models. The highlighted text shows that RNN models outperform CNN using both TF-IDF and hashing vectorizer. And since BERT original model is trained on English, the Sindhi version did not give us a good result, and the English one gave us extremely well results. The analysis of deep learning models, both variants of RNN, simple RNN and LTSM outperform CNN because CNN RNN can capture sequential dependencies and understand contextual meaning of a word within a sentence. BERT is not trained with synthetic language models. Average performance with the translated data, the performance increased by approximately 58.17% when the translated data was used. We will conclude our work by saying the neural network algorithm performed best for our Sindhi dataset using hashing vectorizer feature extractor. RNN as a deep learning model outperformed CNN using TF-IDF feature extractor. Both feature extractor help achieve overall high accuracy, with hashing vectorizer outperforming TF-IDF in terms of accuracy in 8 out of 15 instances. TF-IDF outperformed hashing vectorizer. The limitations of our work were unbalanced dataset, as it was seen in previous sections that the dataset had almost that were labeled translation accurate one. Reference of our work. Thank you.
Mr. Bob, you are not listening. Please check your mic. We're not hearing your voice.
Sorry, sir.
Okay, continue. We are not
Sir,
hearing
can you
your
hear
voice.
me?
You are not. We are not hearing your voice. Maybe your mic.
Sir, should I start again?
No, but just continue from conclusion part.
Um.
again. Okay,
Oh,
anyway,
okay.
anyway.
Okay.
Uh, we have 5 minutes for question and answer. Please start. Anybody has any questions regarding this topic? Okay, it's wonderful presentation, Robab. Please tell me why you are using machine learning technique and deep learning technique, both technique. Uh, you can use only RN, and RN use NLP. Okay, you will use any programming language. You will work on Python. Are you familiar with Python?
Yes, sir. We have. Yes, sir. We have implemented our models using Python.
Using Python. So, what library will you use from Python? What kind of library? Like
Sir, we
NumPy,
used.
Pandas,
Uh,
Scikit-learn, NLP.
sir, we used pandas and multiple libraries to attain best results.
Okay.
So my next question is what you are thinking that how we can improve the accuracy of your algorithm for the Sindhi data?
Sir, because the data we have used is data from Twitter. The tweets are always limited in numbers. There are only 280 characters, if I'm not wrong. So the connection between one tweet and next tweet is very different. We have obtained almost good results, above 90% in almost all our algorithms and models except KNN, because KNN because KNN needs to have some kind of similarity between neighbors. It takes information from a previous neighbor and a next neighbor. So tweets are always different in nature. So the KNN result is really low.
Miss Uma, have you made any model, mathematical
Yes, sir.
model?
No, sir, not mathematical model, but uh, we have developed model using Python on this data set to evaluate this data set.
So, what's your ratio between training and testing? 70
Sir,
30
yes, sir.
ratio between training sets and testing set.
Yes, sir.
You have chosen 70 30 ratio.
Yes, sir.
Okay.
Okay, then thank you for the nice presentation. Then we will move for the to the next presenter.
Okay, thank you, sir.
Osama Shabbi or Zainab?
So
Zainab
from Altamash or Zainab, anyone is online?
Shay Mahmood.
From Altamash and Zainab, anyone is online for the next presentation? Okay, then we will wait for a couple of minutes. Then we will start again.
Shay Mahmood.
So next we are inviting Suhaib Manzoor for the presentation with title Rare Earth Iron Doped Zinc Oxide as a Viable Photoanode Material for Desensitized Solar Cells,
Assalamu
Optical,
alaikum, sir.
Optoelectrical and wettability aspects.
Assalamu alaikum, sir.
Yes,
So,
Akbar Kiani,
so
which
basically,
mhm,
my paper has already been presented, and Dr. Sohail Manzoor is my supervisor. So
okay,
I have presented in place of him. So
okay, you can proceed then.
I am in Azad Kashmir. I have sent you the video, and my paper has already been my video has already been played. The first
Okay,
video
okay,
that was which simulator to choose for next
right.
generation wireless network simulations, NS3 or OMNET.
Okay, we're trying. We're trying.
So there was a mistake on your pamphlet, like you have shuffled the author's name of 69 and 70.
Mm,
Okay.
okay,
Actually, the paper was linked with Dr. Suhaib Manzoor. or
Okay.
FormNet NS3.
I think we received the presentation. Other one also, maybe we can play in couple of minutes.
Sorry, sir.
We received the presentation, I think, for the second presentation also
Okay.
from Mohammed Shuhaib, I think, and we are going to play in couple of minutes.
No, there was only one presentation from Dr. Suhail Manzoor.
It's not a rare earth ion dope.
No, no, no.
Okay. Which
Because
simulator to
yes,
this one? Okay.
because his specialties are wireless communication, so the simulator one was our presentation.
पहला वाला स्वेप था
जी, दूसरी भी
So this presentation has been conducted. Now we have the presentation for paper ID 71. Uh, Title of the paper is Design and Development of Net Metering Based Energy Meter from Altamash Shabir Nust.
Okay, sir. Thank you. Just wanted to clear this matter sort. Okay.
Thank you.
It, okay, sir.
Hmm.
Synthesized solar cells. Assalamu alaikum everyone. I am Alvin Shabir. I am here to present my presentation on the theme of rare earth kind of zinc oxide as a viable photoanode material for dye-synthesized solar cells, optoelectrical and wettability aspects.
In this slide, I will elaborate the overall proceedings of my research. I have fabricated the lanthanum doped zinc oxide nanomaterial, and after that, I have found some sort of findings to elaborate the potency of this material to be utilized as photoanode in dye-synthesized solar cells, in which I have carried out few characterization like XRD, SEM, UV wins, FTIR, all measurements and wettability properties. This is the layout of the presentation: introduction, problem statement, objectives, synthesis, and experimental setup, result and discussion, conclusion, and references. This is the introduction. Before starting the materials discussion about photoanode, it's important to know about the background, that why we need this technology. As we know, renewable energy systems to reduce the GHG emissions and air pollution. There are several number of technologies of renewable energy as wind energy, biomass, and nuclear energy. But photovoltaics is a much promising technology due to its affordability and cost effectiveness. Dye-synthesized solar cells is the third generation of photovoltaics. That includes the several number of components like sensitizers, photoanode, redox, electrolyte, and counter-electrode titania, zinc oxide, tin oxide, niobium oxide is a promising material for the dye-synthesized solar cells for photoanode material. So here's the problem statement. As we know that titania is the material that used as photoanode, but due to its low electron mobility, we are looking towards the zinc oxide due to its high affordability, high electron mobility, and high chemical stability as compared to titanium. Existence of green boundaries can also be modified via doping of rare earth ion. So here's zinc oxide as a photoanode material. It's important to know about the zinc oxide as and as I synthesize solar cells photoanode material. It has appropriate band gap, good conduction level, better electrical mobility, less charge recombinational effect, and this is the basically structure of zinc oxide that we have formed by using the Vesta software. So the question arises why we choose lanthanum as dopant. As we know, rare earth ion have high ionic radii, make it a good choice for as a dopant. Zinc oxide has high band gap, which is about 3 to 3.7 electron volt. 4F interaction in the lanthanum give us high intense peak in visible and IR region, and it's provide high photocatalytic activity as well. So here is the synthesis route for ZNO's nanostructure. So there are several number of methods that can be utilized to form the nanostructures of ZNO. This is the basically ZNO structure, what is hexagonal vertex ZNO structure. So there are several number of routes to deposit or to the formation of ZNO nanostructure by using the solid state route, vapor phase route, or the liquid phase route, and also their streams. So this is the objective of my team to deposit the bare and lengthened of ZNO thin film via wet chemistry route to analyze the morphological and structural optoelectrical and wettability properties of the deposited film, and also want to improve the hydrophilic and optoelectrical characteristics of the depositing films. So this is a synthesis and experimental section. So first of all, recruitment of material. Zinc acetate dehydrate and lithium nitrate hexahydrate acted as solute. Substrate was FTO and silicon. Ethanol, amine, methanol, and ethanol acted as solvent. So here's the experimental setup. First of all, zinc acetate dehydrate and lanthanum nitrate hexahydrate were dissolved in anhydrous ethanol as starting material, and the monoethanol amine was used as a stabilizer and make the film transparent. And after 3 hours of stirring at 70 degree, the solution was homogeneous and clear. Then cool down at room temperature, and after that spin coat the solution at 2500 RPM for 30 seconds. Film was preheated at 180 degree for 5 minutes to remove the volatile from the film, and also done the experiment again and again to achieve the appropriate number of appropriate level of thickness. And then finally the film was annealed at 450 degree for an hour to make the film highly crystalline. So here's the results and discussion. First of all, XRD was used to find out the phase and crystallite size of the material. The peaks appeared in the specific manner and well matched with GCP DS card number 361451. The phase was an organovertized structure. There was a shift in the peak after doping of lanthanum into the ZNO that is structure, and the peak was 34.35 degree to 34.42 degree. So the lanthanum could introduce the distortion inside the lattice structure of the ZNO. Then shifting appeared. So there is a Scherer formula that was used to find out the crystallite size of the material, which was 39 nanometer for zinc oxide and 26 nanometer for lanthanum doped ZNO thin film. This is the morphological analysis. The film were composed of small granule-like structure and spherical-like structure, and the grain size was reduced from 54 nanometer to 36 nanometer after dropping the lanthanum content into the ZNO. So we can say that there was no drastic change in morphology, and EDS and mapping the micrographs shows that the lanthanum was successfully doped or integrate inside the lattice structure of zinc oxide. This is an other technique which is FTIR that can be utilized for the functional group analysis or structural analysis as well. So zinc oxide P present at 591 wave number, and the lanthanum integration into the ZNO structure was confirmed at 687 and 756 wave number. So as you know, there is the carbon content present in the solvent. So these peaks present in the range of 1300 to 2360 wave number, but low in intensity due to the evaporate from the film After annealing at 450 degree, hydroxyl group also present in the range of 20 to 37 wave number. Basically, we can conclude that lanthanum was successfully integrated into the lattice structure of zinc oxide. So here's a UV-based analysis of lanthanum doped ZNO. So UV-based analysis was done to find out the band gap of our synthesized material. So this is the formula. Like top relation was used to find out the band gap that was 3.55 volts, that then no to 3.40 3.40 electron volt for lanthanum doped and thin film. So we can say that after at 5% doping, band gap was reduced and the absorption increased. So basically, the lanthanum doping produces the impurity phase and also the impurity energy level in the band gap, which enhance the visible light sensitivity inside the uh, inside the material. So this type of material can also be utilized in various applications. So we can say that at 5% we achieve low band gap, as we can see over here. So the next property is electrical property. After optical property is very important to know about the electrical property of our desirable material. So after the substitution of the lanthanum inside the Ladon ladder structure, that can increase the concentration of the carrier. So after increasing the concentration of the carrier, the mobility, the conductivity level also improved in the film and also reduces the resistivity in the film. So we achieved optimum result at 5%. The other property which is very important for the absorption of the dye, which is water-burnt rectangle. This is very important property for the photoinvolved material. As we know, more hydrophilic state absorb more liquid. Basically, there are two states of wettability. One is hydrophilic, and if the angle is in between 0 to 90 degrees, the surface is hydrophilic. If greater than 90 degree, the material is hydrophobic. As we can say that at 5%, 5%, the material shows high hydrophilic effect due to good adhesion with droplet. Basically, there are two properties, fundamental properties, such like as work adhesion and surface free energy, that are totally depend on the water contact angle. So this is the phenomena of how wettability properties impact the ZNO and La drop zinc oxide films. So this is the conclusion and future recommendation. So we successfully synthesize the lanthanum doped ZNO thin film via Sol-Gel method. So the crystallite size was reduced after increasing the content of lanthanum inside the that lattice structure, and the XRD pattern reveals the hexagonal vertex structure. Scanning electron microscopy shows granule and spherical-like structure, and the ADX spectra and mapping also confirm the elemental composition of the film. The band gap reduced remarkably 3.55 electron volt to 3.4 electron volt. At 5%, we achieved high level of conductivity and low level of resistivity, but also improved the hydrophilicity level at 5% concentration of lanthanum, 26.40. So by an analysis of these results, we can say that this material can be utilized as a photon material in dye synthesized solar cells in future. So these are the acknowledgement. I really gratitude to my to our lab engineers and my fellows as well, and also my institute to to support me during my research, financial support as well. So these are the references. And finally, I thanks uh, to all of you. If you have any query, please let me know. Inshallah, I will try my best to give you the appropriate answer. Thank you so much.
Thank you, Altamash.
Online.
Online continue होता है अच्छा दूसरा कौन है यार वो बाबू हो गया वो कौन है
आपको जो नेक्स्ट प्रेजेंटर online.
Mohammed Shoaib, Zainab, are you online now? Are you available now? Zainab, any presenter is now online now?
Sir, Mr. Shoaib Salim is going to join us in a moment. He will be presenting the paper with ID number 71, Design
Okay.
and Development of Net Metering Based Energy Meter. He is about to join us in a moment.
Assalamu alaikum, Mohammed Shoaib. Hello. Assalamu alaikum, Mohammed Shoaib Salim. Uh, Mohammed Shoaib Salim, please start your presentation. Mohammed Shoaib Salim, are you hearing me? अस्सलाम वालेकुम मोहम्मद अल्तमश। अस्सलाम वालेकुम मोहम्मद अल्तमश। सीन तो प्रेजेंट किया फिर क्वेश्चन आंसरिंग के लिए कर लेते हैं। मोहम्मद अल्तमश, आर यू रेडी फॉर क्वेश्चन आंसरिंग? कैन यू गिव अस टाइम 5 minutes at least?
और उसके साथ
हेलो
फीड
सर,
लाइन,
अस्सलाम वालेकुम।
इन दोनों की इम्पीडेंस सेम होनी चाहिए,
वालेकुम सलाम।
शुड बी सेम। और ये
सर
है
प्लीज एक मिनट दीजिएगा सिर्फ।
ओके, ये इसने किया था जिंक ऑक्साइड।
यस सर।
किसी क्वेश्चन है, सवाल का है?
जी जी सर। हेलो।
तो अच्छी प्रेजेंटेशन थी अभी। ये बताएं कि आपने जिंक ऑक्साइड में लैंथेनम आपने डोप किया हुआ है,
यस सर।
उसे आपने देखा है एनहांसमेंट।
जी सर।
ऐसे ही अगर ये हम 5% से मजीद बढ़ाएं 6% वी आर मोर lengthenum, then what will be happen?
सर
Reduce
बेसिकली
its
या
proper conductivity.
या बेसिकली बात ये है कि जब हम लेंथनम को 5% से ज़्यादा बढ़ाते हैं तो इसमें रफनेस बढ़ रही थी, जिसकी वजह से जो फोटो एनोड मटेरियल होता है उसमें एड्जॉर्प्शन ज़्यादा होनी चाहिए। जैसे कि वाटर कॉन्टैक्ट एंगल में हमारे पास 26.4 डिग्री आया, मतलब कि ज़्यादा से ज़्यादा डाई का अब्जॉर्ब हो सकती है, हाइड्रोफिलिक प्रॉपर्टी आई है। बट अनफॉर्चुनेटली अगर हमने 7.5 पे या 6 पे किया था तो हाइड्रोफिलिसिटी जो थी वो मतलब कि हाइड्रोफोबिसिटी में कन्वर्ट हो रही थी, मतलब कि 50 डिग्री, यानी कि जो डाई की अब्जॉर्प्शन है उसमें ज़्यादा नहीं हो रही थी। और दूसरा ये है कि इसमें रिकॉम्बिनेशनल इफेक्ट्स वो बढ़ना स्टार्ट हो जाते हैं, जिसकी वजह से हम ये कह सकते हैं कि मतलब कि ये जो है फोटो एनोड मटेरियल ये हमारे सेल्स की जो एफिशिएंसी है वो उसको रिड्यूस करेगा। बेसिकली होता ये है कि जो रफनेस होती है वो हाइड्रोफोबिक बेसिकली बनाती है मटेरियल को, यानी कि वाटर कांटेक्ट एंगल जो होगा वो कम होगा, ज़्यादा होगा सॉरी। तो हमने कम से कम वाटर कांटेक्ट एंगल रखना है, क्योंकि सरफेस फ्री एनर्जी जितनी ज़्यादा होगी या वर्क रीजन जितनी ज़्यादा होगी उसके साथ वो उतना ही ज़्यादा डाई को अब्जॉर्ब करेगा, जो हमारे फोटो एनोड मटेरियल के लिए और जो डायसिंथेसिस सोलर सेल्स के लिए ज़्यादा बेहतर है।
आपने कौन सी टेक्निक यूज की है वेटेबिलिटी के लिए? कोई इंस्ट्रूमेंट यूज किया है वेटेबिलिटी टेस्ट के लिए? आपने जो टेस्ट किया
यस।
है वो जो है जिंक ऑक्साइड को वाटर से और लेंथेनम डोप जिंक ऑक्साइड को फिर वाटर से गए। अगर
यस।
आपने सिर्फ ऐसी ऐसे वाटर के अलावा किसी और से आपने चेक किया वेटेबिलिटी?
बेसिकली जो हमारे पास लैब में फैसिलिटीज़ होती हैं, हम ये देखना चाह रहे होते हैं कि हमारा जो बेसिकली जो फंडामेंटल जो है वो हमारे पास वाटर है वहाँ पे,
ओके,
और उससे हम अंदाज़ा लगा लेते हैं कि मतलब कि हमारी जो इलेक्ट्रोलाइट की अब्जॉर्प्शन जो होगी फोटो एनोड मटेरियल में वो कितनी ज़्यादा होगी।
अच्छा, आपने एक्सआरडी टेस्ट किया था, उसमें आपने लेटेस्ट पैरामीटर नहीं निकाला और आपने उसमें देखा इसमें मॉर्फोलॉजी
यस।
सॉरी उसमें क्रिस्टलिटी कितनी है? ज़्यादातर ऐसा आ रहा था कि कम है क्रिस्टलिटी, बिल्कुल इसमें आ रहा था क्या कहते
जी
हैं जिसमें
सर।
सिरामिक।
बेसिक या यू आर एब्सोल्युटली राइट सर। बेसिकली सर लेटेस्ट पैरामीटर्स को हम निकाल सकते थे नो डाउट, क्योंकि हमने पीडीएस कार्ड नंबर जैसे कि मैंने लिखा हुआ है उसमें, तो वो उससे वेल मैच कर रहा था। बट क्या है उसमें नॉइस ज़्यादा आ रही है, लेकिन पीक्स हैं वो अपनी पोजीशन पर आ रही हैं, तो हम ये कह सकते हैं कि ये मटेरियल क्रिस्टलाइन है। बट मतलब कि इतना ज़्यादा उसके अंदर क्योंकि दो चीज़ें होती हैं इसमें, एक तो मशीन एरर भी हो सकता है, क्योंकि जब एन लैम्डा इज इक्वल टू डी साइन थीटा, मतलब कि जब वेव आएगी तो वो उस तरह वापस नहीं जा रही, जिसकी वजह से नॉइस भी बन सकती है, तो मशीन एरर भी हो सकता है। बट जो पीक्स की जो डायरेक्शन है और जो पीक्स की जो प्लेन्स आ रहे थे हमारे पास, वो बेसिकली उसी जगह पर आ रहे थे जो जैसे पीडीएस कार्ड नंबर जो हमें गिवन है उसके मुताबिक ही वो बन रहे थे।
तो आप नर्स कौन से कॉलेज से बिलोंग करते हैं, स्कूल? एससीएम?
बेसिकली मैं यस नो सर, यूएस पाकिस्तान सेंटर फॉर एडवांस स्टडीज एनर्जी,
ये
यूएसपीके।
नर्स नर्स के अंदर ही है या
जी
बाहर है?
सर, ये यूएस फंडेड है डिपार्टमेंट है जो एक्चुअल उसमें है
ओके,
नस्ट में।
अच्छा। अच्छा, एफटीआई में आपने कोई कंपाउंड आपने निकाला या
ये
एफटीआई एनालिसिस किया था आपने कोई? कोई मालूम है कंपाउंड या कोई दूसरी ऐसी
बेसिकली
कोई मटेरियल?
ओके सर। सर बेसिकली होता ये है कि एफटीआईआर स्पेक्ट्रोमीट्री के अंदर हम बेसिकली फाइंड करते हैं ऑर्गेनिक एंटी सिमेट्रिकल बॉन्ड्स। सिमेट्रिकल नहीं, बेसिकली ज़्यादातर एंटी सिमेट्रिकल बॉन्ड्स होते हैं। उसमें होता ये है कि हमने ऑर्गेनिक मॉलिक्यूल्स के अंदर उसकी प्रेजेंस कितनी, यानी कि कार्बन कार्बन कंटेंट इसके अंदर पाया जा रहा है, क्योंकि इसके अंदर हम सॉल्वेंट्स वगैरह इस्तेमाल कर रहे होते हैं। उसके बाद हमने जिंक ऑक्साइड और लैंथनम की डोपिंग को भी हम फाइंड आउट कर सकते हैं, क्योंकि जो पीक्स जो आ रही होती हैं, बेसिकली जो वाइब्रेशनल पीक्स या बेंडिंग पीक, स्ट्रेचिंग पीक्स आ रही होती हैं, उससे हम ये अंदाजा लगा लेते हैं कि ये हमारा मटीरियल जो हमने बनाया ये फैब्रिकेट हुआ भी है कि नहीं हुआ।
अच्छा, तो आप जो है एफटीआई में आईआर जो है कौन से रीजन को फॉलो कर रहे थे? किस रीजन को आपके
यस।
लिए ज्यादा वो स्टडी मतलब बेनिफिशियल है?
ओके
मतलब मिड
सर।
इंफ्रारेड या नियर इंफ्रारेड?
बेसिकली सर जो एफ टी आई आर रीजन होता है ना, वो बेसिकली होता है फॉर आई आर रीजन होता है, जो विजिबल यूवी, और जो नियर इंफ्रारेड रीजन होता है वो बेसिकली आपका होता है यूवी विज का। ठीक है, जो आप अगर फार की तरफ चले जाते हैं वो आपका एफ टी आई आर होता है। अच्छा, अब हमने बेसिकली इसके अंदर से हमने जो पीक्स फाइंड किए हैं, बेसिकली हमारा फार इंफ्रारेड रीजन में जाके उसमें होता ये है कि हम इसमें जो कॉरेस्पॉन्डिंग पीक्स होती हैं, जो कि प्लेन्स जो कि पीक्स आ रही होती हैं, उससे हम अपने मटेरियल को देखते हैं कि इस तरह के बॉन्ड्स वगैरह हमारे मटेरियल के अंदर बन भी रहे हैं कि नहीं बन रहे, इनकॉपरेशन जो है लेंथनम की या फिर किसी भी डोपेंट की इसके अंदर हो भी रही है कि नहीं हो रही। बेसिकली ये वजह होती है। 2500 नैनोमीटर से 36,000 समथिंग नैनोमीटर तक की इसकी रेंज होती है एफ टी आई
यानी
आर।
आप एब्जॉर्बेंस से आप ये देख सकते हैं, अब ये यही मटेरियल होगा, अब ये
यस सर,
कंपाउंड
मैंने
होगा।
कॉरेस्पॉन्डिंग जो पीक्स आपने देख रहे होंगे जिसके ऊपर मैंने लेबलिंग भी की हुई है, वो हमें बता रही होती है कि मतलब ये हमारा मटेरियल बना भी है कि नहीं बना। अगर पीक्स नहीं आएंगे तो जाहिर सी बात है कि वो उसकी कोई डायरेक्शन नहीं दी, क्योंकि जब आप सिंगल फिटॉन फिनोमिना होता है, जब वो फिटॉन अंदर जाएगा तो स्ट्रेचिंग होगी, बॉन्ड्स की वाइब्रेशन बेंडिंग होगी, या फिर वाइब्रेशन बेंडिंग और स्ट्रेचिंग होगी। ये तीन बॉन्ड्स मतलब कि तीन फेनोमिना होते हैं, मोड्स होते हैं उसमें।
अच्छा, आपने 5% ऐड करने पे लेंथनम तो
जी सर।
कंडक्टिविटी बढ़ गई थी।
जी
क्या
सर।
ये ऑप्टिकल प्रॉपर्टी इन्हांस हुई थी, मिसाल के ट्रांसमिटेंस प्रॉपर्टीज या कोई और?
सर बेसिकली फोटो एनोड को हमारा जो डायरेक्टली कंसर्न होता है वो हमारी अब्जॉर्प्शन के साथ होता है, कि फोटो एनोड जो है हमारी सोलर रेडिएशन को कितना अपने अंदर अब्जॉर्ब कर रहा है। दूसरा ये है कि अगर कंडक्टिविटी की बात की जाए, नो डाउट कंडक्टिविटी बढ़ रही है, लेकिन उधर से वाटर कॉन्टैक्ट एंगल भी कम हो रहा है, ज़्यादा बढ़ रहा है, यानी कि हाइड्रोफोबिक बन रहा है। तो हमारा अल्टीमेटली जब हम फोटो एनोड मटेरियल बनाते हैं तो उसको हमने डाई के अंदर एब्जॉर्ब करना होता है कुछ आवर्स के लिए, 24 आवर्स के लिए, 36 आवर्स के लिए, कि डाई को अपने अंदर अब्जॉर्ब कर ले अच्छी तरह, ताकि वो फिर जब एक पूरा फिनोमिना होगा तो उसमें ये जो मूवमेंट होती है बेसिकली चार्जेस की, उसको स्मूथ बनाती है, तो वो कम हो रही थी।
रियली थैंक यू फॉर योर टाइम अल्तमश।
ठीक है सर, हैव अ नाइस डे सर।
थैंक यू।
Respected chairs, now we have presenter Mr. Shoaib Salim, uh, paper ID 71, with the title Design and Development of Net Metering Based Energy Meter. Mr. Shoaib Salim, you may come online and present your paper.
Mohammed Shoaib Salim, are you hearing us? Are you available? Ready for your presentation? Mohammed Shoaib? Assalamu alaikum, Mohammed Shoaib. Assalamu alaikum, Mohammed Shoaib Salim. Hello, Mohammed Shoaib Salim, could you hear us? Mohammed Shoaib Salim, please share your presentation. Mohammed Shoaib Salim, we have limited time. Please share your presentation. If you're feeling any difficulty, please text us.
Assalamu alaikum, Mohammed Shoaib, can you hear us?
Zainab. Assalamu alaikum, Ms. Zainab Muin. Can you share your presentation? Can I start from you?
Yes, sir.
Okay, are you ready
Yes, sir.
now? Okay, thank you,
Yes, sir,
Zainab.
I'm ready.
Please start.
Can you see it? Is it
Yeah,
sharing?
yeah.
Okay. Assalamualaikum everyone. My name is Zainab Abeen from University of Gujarat, Hafiziyat campus, and I'm thrilled to be here at 8th International Electrical Engineering Conference to share my research work with you. The title of my research is Design and Implementation of Prepaid Energy Meter with Home Automation and Peak Load Management with Android application. I have had the privilege of working alongside my talented co-authors Tayyib Tahir, Talha Irfan, Atif Aslam, Mohammad Fahad, and Dr. Sher Rauf. In the next few minutes, I will take you through our journey from concept to implementation, highlighting how our work addresses real world challenges and contribute to the field. Thank you for being here. So let's get started. Number one is introduction. As the title suggests, this smart meter performs three main tasks: prepaid billing, home automation, and the third one is peak load management. And all of these are done through Android application. So for this purpose, we have designed a smart kit that is compatible with any single phase energy meter. This energy meter measures line voltage, load current, real-time power obtained by load power factor, consumed load type, either light load or power load. To measure line voltages, we have used potential transformer, and for the load current, we have used current transformer. A Firebase, Google Firebase is used to develop smart peak load management system, and to calculate power factor and energy, we have designed a program-based algorithm. For home automation, Android application is also designed. Now, the question arises, what was the need to devise such a system in the first place? As we know, in Pakistan, there is no such system for real time monitoring and home automation, and there is no system for peak load management. The next one is aims and objectives. As I have explained earlier, the main aims of our meter is to perform three main tasks, which are prepaid billing, home automation, and peak load management. The components used in making our smart kit are ESP32, Arduino, OLED display, single phase energy meter, potential transformer, current transformer, electromagnetic relay, step down transformer, optocoupler, potentiometer, and electrical loads. This is a complete circuit diagram of our project. Complete circuit diagram of this smart kit is divided into basically three main circuits. Number one is power supply circuit, controller circuit, and high voltage circuit. In the power supply circuit, there is a supply from water and a step down transformer that steps down 220 volts into 12 volts. These 12 volts are further converted into 3.3 volts and 5 volts by using buck converter and LM7805 respectively. These 5 volts are used for operating Arduino and for switching of relays, and 3.3 volts are for ESP and OLED. Here in the controller circuit, you can see I2C communication is done between Arduino ESP32 and OLED display. Here in ESP32 is working as a master, and OLED and Arduino are its slaves. Relays are connected with ESP32 for switching of load in a high voltage circuit. We have connected both light load and a power load. You can see in this diagram. These are connected with respective relays. Current transformer and potential transformer are also connected there. So next one is methodology. The methodology of our research is a program-based algorithm is developed to calculate power factor and other load parameters. I2C communication between master and slave, responsibilities of master and slave, Firebase, Google database, home automation, and peak load management. The next one is responsibilities. Here are some responsibilities of slave. Number one is it light voltage is using potential transformer. It creates pulses from energy meter, calculates consumed unit, remaining unit, load consumed unit, load power and power factor. It sends data to master on request. And some responsibilities of master is it interfaces with Wi-Fi, authenticates with database, which is Firebase Google. It communicates with Arduino. It interlinks with OLED display. It fetches data like consumed unit, remaining unit, amount, rate, etc. from database. It auto restarts itself in case of recharge. It sends data to slave continuously, and it receives data from slave and upload to the database and OLED. It also checks status of load point from database for home automation. And the last one is peak load management. The next one is database. Here you can see a screenshot of Firebase Google. Here you can see some tags and tag values. These PS1, S1, S2, and S3 are load points. Amount is the credit entered by the user. Current peak start and peak stop for peak hours for load management, power factor, rate, etc. These are some tags and tag values. The next one is unit measurement. For unit measurement, which post at the LED blinks for 32 times. So to calculate a credited unit, we have used this formula, that is the ratio of amount entered to rate per unit. So by using this ratio, we got 0.03125 units per blink. So that means with every single blink, 0.03125 units will be increment in consumed unit and decrement from remaining unit continuously. If credited units are less than 1, it will show message like please recharge on OLED. And if credit units are 0, ESP will restart itself, will re-update remaining kilowatt hour, that is a tag, to 0, and it will disconnect all load. And if a person recharge, ESP will restart itself and also push restart Arduino. The next one is home automation. Home automation, we know home automation is basically a automatic and electronic control of household features, activities, and appliances. So for home automation, we have used Android application, which is connected with database. And here you can see these are the tag values of some load points. PS1 is for power load, and S1, S2, and S3 are for light load. The next one is peak load management. Uh, Peak hours are hours of the day during which the demand of electricity is high, as you all know. So for this purpose, we have used the server bit time synchronization protocol, that is network time protocol (NTP). Peak start time and peak off time are set by the company on database. When a peak start time is synchronized with NTP, power load will be turned off and until peak off time ends. So this is the screenshot of Firebase. Now, here is the anti-theft protection in our system. Our system is designed for 2 ampere and for supply is 250 volts. So now, out of 2 ampere, 1.2 ampere for the light load and 0.8 for the power load. So during the peak hours when the light load is on and the power load is off, if a user tries to connect power load on the light load terminal, system will wait for 4 seconds.
to check whether it is done by some mistake. If it was a mistake, then the system will restart itself and all light load will continue running. But if a user did it by some choice, then the system will indicate the theft and it will completely shut down and including all loads. It will remain off for about 4 minutes to punish user, and after 4 minutes system will turn on. This code shows these things. The last one is Android application. We have, as I have told, we have done all these tasks through Android application. So for Android application, we have developed Android application using Codler. This is the user interface of our Android application. Here two screens are added. One is for login and sign up. It has two grids, sorry. And for monitoring, the next one, the other one is monitoring screen, and it has three gates. All of this coding is done in a block section of Kotlin. In the results, the design smart energy meter perform all defined functions, like it measures all power quantities of power triangle. It's safe and easy to understand design of Android application for monitoring, data monitoring, and Android application user data encryption using Firebase for Android application is also added. Energy meter is designed for 10 ampere single phase load only, but it can be modified for higher load. This is the final model of our project. In a conclusion, I want to say an Android based IoT based prepaid energy meter is developed by using two controllers. Special features like prepaid billing, home automation, peak load management are introduced by the mean of Android application. We have designed and also tested prepaid energy meter through disconnection of power load during peak hours, and also tested the anti-theft protection in case of peak load management. The proposed meter can be used in practical to achieve the targeted goals and objectives. Thank you. That's it.
Thank you, Ritu. Sarah, wonderful your presentation. I have a question.
Yes, sir.
Will you use any analytical technique such as Power BI, Microsoft Power BI, etc.?
Sorry, sir. I don't get it.
Will you use any analytical technique like Power BI technique? It would be good for your research, I guess.
No, sir.
You won't use any analytical technique. Why not?
Sir, yes, sir. We will try.
Okay, great. Any questions? Okay, thank you, Zara. Now we are moved to next presenter,
Thank you so much.
which is Muhammad Shoaib. Muhammad Shoaib, are you ready now?
जी
Can you
अस्सलाम
share
वालेकुम.
your presentation?
Yes,
Thank
I'm
you.
ready, sir.
Okay, thank you.
Should I start, sir?
Yeah, now we can see.
Okay, thank you. Bismillahirrahmanirrahim. I am Engineer Muhammad Shoaib Salim. I am currently affiliated with University of Management and Technology, Sialkot
Please
campus.
move to presentation mode in your slides. We cannot see.
Okay. Is it sharing, sir? My screen is visible?
Coming, but not the presentation view. It's not like full screen. Maybe you share the wrong window.
Please press F5 button. Yes.
Can you see my screen, sir?
Yeah, it's coming now. But not again, not the full screen. Can you now press F5? Or yeah,
It's okay now, sir?
it's still not. Okay, you can continue as it is.
Okay, thank you. Bismillahirrahmanirrahim. My topic of presentation is design and development of net metering based energy meter. This is a bidirectional meter which keeps records of imported and exported energy meter during the specific time. Uh, this project has actually two energy sources. One is the utility and other is photovoltaic panels that are installed on the rooftop. Photovoltaic panels cannot generate power during night, so users have to import power from the grid to fulfill energy demands. At the end of the month, utility charges consumers according to the net balance of the energy meter, depending upon if the imported or exported energy, which one is higher. The designed bidirectional meter is an IoT-based meter which allows consumers to monitor power rating of the load. And for this purpose, an Android application has been developed. Electric power system consists of power plants that are located at remote locations, and they need a lot of long transmission lines, feeders, substations, distribution substations for the delivery of energy to the end consumers. The advancements in the field of technology, heavy machines, smart controls took over the industries and dominate the labor work for mass productions. Smart grid is a new concept in the electrical engineering field, and engineers, researchers are progressing to find better solutions to overcome the line losses. Net metering system is required to measure two energy values, that are imported energy from the grid and exported surplus energy that are built in house inside the house through the photovoltaic panels. The grid-tied inverter is a three-stage smart inverter and supplies load power according to the solar energy produced. When generated energy is surplus, then the demand, the extra energy will be supplied to the grid. Microcontroller reads this exported energy by measuring the current value. Microcontroller differentiates between the exported and imported depending upon the traffic by checking the sign of the current value. So sign of the current will uh, differentiate that energy is coming from the grid or going towards the grid, whichever is the case. So methodology of the project is that in the design energy meter, we divide it into two subsections. That one is for the AC values measurement and second is for the DC values measurement. Both sections have separate microcontrollers and between which one is the master and other is the slave controller. To measure the power factor and load power, we need to measure line voltages and currents, and for these purposes, we are using PTs and CTs. PT is used to measure high AC voltages, and it is connected to the microcontroller ESP32. The meter is calibrated into 32 pulses per kilowatt hour, and Arduino microcontroller is employed to handle all charge controller applications. The grid current sensor measures the amount of current being supplied or delivered from the mains. Arduino microcontroller reads the data from the connected sensors and transmits the master controller through I2C communication. So my master controller communicates to the conventional energy meter by counting the pulse signals. So this is actually an additional kit that can be connected with the ordinary energy meter installed at our homes. The conventional energy meter only measures consumed units no matter power is being supplied or consumed. The conventional meters which are installed at our homes, ordinary single phase meters, are not capable of identifying the direction of the energy flow. They will only use incremental to count the units, but they cannot differentiate between the direction of the power being flowing. Whenever high pulse signal receives from the conventional energy meter, it will initialize and interrupt to increment in unit value. Home automation feature. The use of internet allows the user to monitor and communicate with the device using internet. Energy meter measures the load and charge controller data and uploads this data to the central database. The Android application reads the data from the database and displays on the application screen. Application also checks the status of the load switches throughout the system with the help of the database. To turn on a load, user taps on the corresponding load switch inside the application. The load switch also toggles from off state to on state. Data will be updated on the database. This updated value will be recognized by the microcontroller and turn on the load. Android application development. For the development of any Android application, the official tool called a Standard Development Kit or shortly SDK is used. It is a complete set of instructions and libraries that require the design of the application. There are two screen windows for any Android application. The first is based on icons and called the user interface. The user only see this screen on the screen of particular device you are using, while the other window is used for linking or programming of each component placed in the interfacing screen. So this is actually the main block diagram of the project. User can interact with the meter through the smart phone and mobile application, which is wireless connected to the through internet to the smart home, and you can monitor your loads connected, current metering values, how much energy is imported and exported, and you can also control the loads you want to keep switch on or switch off at the particular time. So circuit diagram and working of the project is that we are using 5 relays for the switching of load through home automation. It consists of current transformer and potential transformers to measure the load current and line voltages respectively. So below figure is for the high voltage circuit in which 5 relays are working to control the loads. Results of the project are that small scale consumer level solar systems are considered instead of heavy investments projects. For measurement of energy flows of these systems, bidirectional energy meters are installed on the premises of the prosumer. So this smart energy meter is designed to provide better and affordable solution to the power utilities. Main concerns of the utilities are power theft, bill recovery problems, and data monitoring. The proposed model is capable to overcome these issues and provides an option for home automation for household users to switch remotely. The smart energy meter is divided into two sections, AC and DC subsections. AC section of the meter is based on ESP32 microcontroller connected with CT and PTs to measure load current and line voltages respectively using CTs and PTs. Two energy values are calculated. The base of the calculation are two values. That one is for energy imported from the grid when your photovoltaics are producing less energy than your requirement.
That's the problem.
And the other value is exported energy when produced energy from the solar photovoltaic panel is
Excuse me, Mohammed Shoaib, your screen is not changing. Means for some reason the slide is stuck.
okay.
Yeah, it's now changing.
It's changing. Okay, thank you. So the DC section of the master is responsible for solar power management, pulse reading, and battery management system. It consists of Hall effect type current sensors used to measure solar current, battery current, and grid mains. Uh, Basically, these are the three main currents. Arduino UNO is used to read data from the current and voltage sensors and transmits data to the master ESP32 microcontroller. Arduino constantly monitors the voltage levels of solar panels and battery, the energy that is stored in the battery at that current time, and changes the duty cycles of pulse width modulation signal to control the output of the solar module. Arduino is programmed according to the protection, and power flow levels of power inverters available in the market. The overall efficiency of battery management system BMS and charge controller is 85% at 30 volt DC. The efficiency will be higher at higher DC voltages, but currently at a prototype level, we are using 30 volt DC levels. So, scopes and future of the study are that this meter is an IoT meter which connects the internet to transmit receive data remotely. ESP controller and Arduino are the base for the connection. So, different modifications can be performed as per the requirement of the user or the utility or the consumer to meet the particular application. So, concluding my presentation, smart net metering based energy meter works on the principle of IoT for real time monitoring and controlled by Android application for the design and implementation purposes. ESP32 is used as main microcontroller to perform power factor measurement, AC power calculation, line voltages, and home automation. Built-in solar charge controller and battery management system are designed using Arduino microcontroller. The overall efficiency of the charge controller at low DC voltages is 85, and this paper proposed a tempering-free meter solution using cloud storage method and blockchain. This smart energy meter can reduce the heavy loads of UPS batteries when no blackouts occur in area, so light loads will keep serving during the peak hours. Home automation can help users to monitor and control the connected load remotely. So this is the end of my presentation. Any questions you people have are welcomed.
Thank you. Any questions from Mr. No? Okay. Shiv, are you using any API? I mean, you for UI user interface like Flutter? You
No, sir.
making the
Currently,
UI from
currently,
Flutter?
no, sir. Currently, we are not using UPI. Actually, this was a custom-made project in collaboration with the local distribution company, Disco, the name Gujranwala Electric Power Company. So this was designed to install at the vicinity of our local industries, sports manufacturing industry in the Sialkot, to keep record of the both incoming and outgoing units, and especially to restrict the theft and monitor the power factor.
Thank you, Mohammed Shiv, again. Really
Sir,
wonderful presentation.
thank you,
Now,
sir.
this technical session 4 is about to end. Five presenters have been presented. So now I would like to thank you all presenters, Mohammed Shoaib Manzoor, Rubab Roshan, Atamash Shabir, Zainab Mubin, and all listeners. Thank you.
Sir, thank you.
Thank you everyone for attending. This session is now going to be terminated. The online video shall be available on YouTube. The link shall be provided later.
पाकिस्तान में क्यों वायबल है, क्यों करने चाहिए। तो इसका रीजन ये है कि पाकिस्तान जो है, एक तो सबसे पहले नेट जीरो डीकार्बनाइजेशन एंड क्लाइमेट द वेरी फर्स्ट ड्राइवर। सेकेंड आपके पास ये कि इलेक्ट्रिसिटी डिमांड तो ग्रो हो रही है, बट उसके साथ साथ टैरिफ भी पाकिस्तान में बहुत इंक्रीज हो रहा है। मतलब रिसेंटली आपके पास अगर मैं इंडस्ट्रियल परस्पेक्टिव से देखूं तो इंडस्ट्री में 2020 में तकरीबन 13 रुपीज पर यूनिट आपको मिलता है, और आज जो है ऑलमोस्ट 48 रुपीज पर यूनिट मिलता है। और अभी जो रिसेंट इंक्रीज हुआ है वो 7.5 रुपीज का हुआ है, और इसमें डिफरेंट इनपुट्स है। पाकिस्तान में जो दो चीजें हैं जो कि पहले ये आजकल अभी जो हॉल्ट हुई है, कि स्टेट बैंक ऑफ पाकिस्तान ने स्पेशल फाइनेंसिंग दी थी 6% पे रिन्यूएबल प्रोजेक्ट्स को प्रमोट करने के लिए, जो कि इस टाइम थोड़ी सी ऑन हॉल्ट है। लेकिन ये कि पाकिस्तान को अल्लाह ताला ने रिन्यूएबल पोटेंशियल बहुत ज्यादा दी है। सोलर ऑब्वियसली हमारा 350 दिन साल में एवरेज जगहों पे मिल रहा होता है, और विंड कॉरिडोर्स हैं बहुत सारे। तो ये हमें बहुत से ऑप्शंस अवेलेबल हैं जो पाकिस्तान के अंदर हमें कहते हैं कि हमें इस तरह मूव करना चाहिए। इसी तरह ये ग्राफ लगाया मैंने ब्लूमबर्ग का कि जो लेवलाइज्ड कॉस्ट ऑफ एनर्जी है वो सोलर और विंड की सबसे सस्ती है पूरी दुनिया में। कि आपके पास एक और ड्राइवर क्या है कि सोलर और विंड का सबसे सस्ती बिजली बना। तो ये आपके पास ऑप्शन है कि यार रिसोर्स अवेलेबल है, कैपिटल के वाइज या एनर्जी के वाइज आपकी सबसे सस्ती बिजली इससे बनती है, तो आपको इसकी तरफ शिफ्ट होना चाहिए इंडस्ट्री को। क्यों नहीं हो रहे उसको हम थोड़ा सा डिस्कस कर लेते हैं। और इसमें थोड़ा सा ये कि मैं एक लीगल फ्रेमवर्क को जरा सा बता रहा हूँ कि किस अंडर द किस लीगल फ्रेमवर्क के अंदर ये परफॉर्म करते हैं, क्योंकि वहाँ पे इश्यूज है जिसकी वजह से ये आगे नहीं बढ़ पा रहे। और उसमें ये कि हमारे पास जितना भी इलेक्ट्रिसिटी सेक्टर है, जो पूरा पावर सेक्टर है, वो अंडर द नेप्रा एक्ट गवर्न होता है, जो हमारा 2018 में रिसेंट अमेंडमेंट हुई थी। इसके तहत अब ये लोग शिफ्ट कर रहे हैं कॉम्पिटिटिव ट्रेडिंग बायलैटरल कॉन्ट्रैक्ट्स के ऊपर। गवर्नमेंट चाहती है इन फ्यूचर, अभी थोड़ा सा टाइम है, कि आप कंपनीज भी जो है वो सारे एग्रीमेंट करके डायरेक्टली यूज करें, बजाय इसके कि आप यूटिलिटी करें। पॉलिसीज मौजूद है पाकिस्तान में, पेपर वर्क पूरा है, बट ये कि प्रैक्टिकल नहीं हो रहा। जैसे अल्टरनेट रिन्यूएबल एनर्जी पॉलिसी 2019 इंक्रीड है, एनईपी पॉलिसी 2021 है, वो भी रिन्यूएबल को के बारे में प्रमोट कर दी है। क्लाइमेट चेंज पॉलिसी 2021 मौजूद है। नेशनल एक्शन प्लान जो कि आपने इंटरनेशनली सस्टेनेबल डेवलपमेंट गोल्स जो यूएन के हैं उसके अगेंस्ट आपने एग्री किया हुआ 2019 का मौजूद है। तो सब चीजें कहती हैं कि रिन्यूएबल की तरफ जाना है, बट ये कि आप जान और इश्यूज जो है वो ये है कि आपके पास ये जो नया मॉडल आप ला रहे थे इलेक्ट्रिसिटी, जिसके थ्रू आपने ओपन कर दी थी मार्केट के, यार लोग के इलेक्ट्रिक के अलावा इंडस्ट्री किसी और से खरीद ले, वो अभी तक उसकी कमर्शियल ऑपरेशन डेट नहीं है। जुलाई अगस्त में था कि यार ये हो जाएगा स्टार्ट, बट यहाँ पे आके एक तो गवर्नमेंट चेंज की तरफ जा रही थी। तो इसमें जो मैं आपको बता रहा था कि ऑफ साइड पीपीए पे आपको एक बिलिंग कॉस्ट देनी है, वो बिलिंग कॉस्ट अभी तक नेपरा ने डिटरमाइन की, तो ये पेंडिंग है अभी तक। इसी तरह आपके पास कमर्शियल कोड पेंडिंग है, ये चीजें होंगी। और नाउ वी आर एक्सपेक्टिंग कि जिस तरह चल रहा है कि अप्रैल 2024 के बाद जाके शायद ये आगे मूव हो, बट स्टिल ये ऑन पॉइंट। और इसी तरह जो डिफरेंट चैलेंजेस है इसको हम थोड़ा डिस्कस करके क्लोज करते हैं। वो ये है कि आपके पास 3 तरह की ब्रॉड कैटेगरीज में मैंने डिवाइड किया है। एक तो लीगल चैलेंजेस है कि अभी तक आप एक तो ओवरऑल पावर सेक्टर में लॉन्ग रन पॉलिसीज का इशू है, प्लस ये कि आपकी जो एग्जिस्टिंग डिस्कोज है, मतलब लेस्को, वेस्को, हाइस्को, एली वगैरह, इनकी तरफ से रेजिस्टेंस है नए मॉडल की तरफ जाने में कि यार आप डायरेक्ट परचेज करेंगे, उसके ऊपर इश्यूज हैं। और इसी तरह आप पाकिस्तान में कोई भी कार्बन टैक्स पॉलिसी नहीं है, कोई रिन्यूएबल सर्टिफिकेट की पॉलिसी नहीं, जो कि पूरी दुनिया में इस टाइम चल रही है, इसको प्रमोट कर रही है। और फाइनेंशियली आपके पास जो सबसे इम्पोर्टेंट है, एक तो ये कि आपको यूजर सिस्टम चार्जेस के बारे में अभी तक नहीं पता कि आपने कितने पैसे पे करने। दूसरा ये कि आपके पास स्टैंडर्ड कॉस्ट ऑफ क्रॉस सब्सिडी इस टाइम बहुत बड़ा एक फैक्टर है जो ऑन हॉल्ट है। अच्छा, टेक्निकल में भी डिफरेंट इशूज है, जिनमें वन एक जो बहुत इंपॉर्टेंट है वो ये कि ट्रांसमिशन और डिस्ट्रीब्यूशन सिस्टम की कंस्ट्रेंट्स हैं आपके पास इस टाइम के, जो कि आपको बिलिंग के बारे में इश्यूज करते हैं। और एक और जो इशू है वो है लैक ऑफ लोकल मैन्युफैक्चरिंग। आपके पास सोलर और विंड के बातें बहुत कर रहे हैं, बट हमारे यहाँ पे टोटल हम इम्पोर्ट करते हैं, सोलर पैनल हम इम्पोर्ट करते हैं, ये हमें तो पूरी दुनिया में ये रिन्यूएबल क्यों हो रहा है सबसे ज्यादा, उसके 2 मेन फैक्टर्स हैं जो मैंने यहाँ पे, और पाकिस्तान में भी अभी इम्पोर्ट है। तो ये कि एनर्जी के अंदर हम एनर्जी की बात करते हैं कि अफोर्डेबल एनर्जी, सस्टेनेबल एनर्जी है, सिक्योर एंड इस तरह जितनी भी इंडस्ट्रीज हैं वो ESG के ऊपर काम कर रही हैं, इन्वायरमेंट, सोशल एंड गवर्नेंस। और एक पुश है पूरी इंडस्ट्री के अंदर कि अगर आपने आगे बढ़ना है, मतलब खास तौर पर जो एक्सपोर्ट इंडस्ट्री, आपके यहाँ टेक्सटाइल है जो एक्सपोर्ट करती है, तो जो उनके कंज्यूमर्स हैं जो कि यूरोप में बैठे हुए, US में बैठे हुए, वो कहते हैं कि हमें अपने ESG गोल्स आप बताएं क्या है, आपके सोशल गोल्स क्या है, एनवायरमेंटल गोल्स क्या है, आप रिन्यूएबल एनर्जी 100% यूज करें। अगर आपका कार्बन फुटप्रिंट है तो वो आपके ऊपर टैक्स लगेंगे। अभी यूरोप ने एक नई पॉलिसी कार्बन बॉर्डर टैक्स मैनेजमेंट के नाम से निकाल दी है, जो कि अगले 1 से 2 सालों में आपके पास जब इम्पोर्ट करेंगे तो उससे एक्स्ट्रा टैक्सेस लगेंगे। तो ये रिकमेंडेशन है कि आपके पास मार्केट को ओपन किया जाए, जिसमें से आपका ग्रीन चार्जेस हो, इसी तरह ग्रीन फाइनेंसिंग पाकिस्तान में अवेलेबल हो, और जनरली ये पॉलिसीज गवर्नमेंट ऐसी बनाए जो कि फेवरेबल हो इन टर्म्स ऑफ रिन्यूएबल और PPA के अगेंस्ट, तो ताकि ये चीज़ें आगे बढ़ सकें। तो ये जस्ट एक चार्ट है दिखाने के लिए, ये सोलर और ये विंड का, ये हमारे विंड कॉरिडोर्स हैं जो कि आपको जहाँ पे रेड नजर आ रहा है, यहाँ पे बहुत ज़्यादा हाई रेट्स हैं जहाँ से आप विंड एनर्जी एक्सपेक्ट कर सकते हैं। इसका सोलर में आपके पास येलो इज फाइन, बट जहाँ पे आपके पास थोड़े डार्क है वहाँ पे बहुत ज़्यादा एनर्जी है जो कि आप ले सकते हैं। खासतौर पर आप ये मिड रीजन और बलोचिस्तान के रीजन हैं वो बहुत अच्छे हैं, उसके बाद से आप एनर्जी एक्सपेक्ट कर सकते हैं। So this is a brief overview for the renewable energy. If anyone have any questions, so they can ask. Thank you. So any questions, please? Yeah, go ahead to the next session. Thank you.
Thank you so much. Thank you very much, sir, for enlightening us. Moving forward, I would like to call Sayyida Hamza Shahid from LAD University of Engineering and Technology to represent her research paper on correlation method based on line condition monitoring of 120 kV rated on ZNOSA.
हम नेक्स्ट शुरू करवाते हैं, अगला शुरू करवाते हैं, तब मिल जाएगी। नेक्स्ट भी नहीं है हमारे पास, बस आपके नहीं दो और हैं, अभी कोई है, आप हैं, मिनिमाइज किए भी लगा दी ना, जल्दी से जाके ना
The name of Allah, the most beneficent and the most merciful. Assalamu alaikum and a very good afternoon to all. This is Sayyida Fantasy and I'm delighted to be here today to present my paper on online condition monitoring of 120 kV oxide search register using correlation method. I would like to start by expressing my gratitude to the organizer of this conference for providing me with the opportunity to share my research with such a distinguished person. I'm very thankful to our advisor, Dr. Abdullah Munir, and my teammates for their cooperation and their support throughout the process. So let's first discuss what are the surge registers and why their condition monitoring is necessary. Surge register acts as an low voltage limiting device to protect the transmission and distribution system from high voltage surges caused by severe lighting and switching operations. But aging and degradation can affect their effectiveness. Therefore, their condition monitoring is necessary to ensure the reliability of the power system. Actually, two methods are employed for the condition monitoring of the surge register. The first one is the online condition monitoring, and the second one is the offline condition monitoring. Online condition monitoring is based on the measurement of the total leakage current, which has two components: the capacitive component and the resistive component. The variation in environmental factors have a more noticeable effect on the aging of zinc oxide surge resistor, and particularly in the resistive component of the surge resistor. Therefore, it is adopted as the most reliable aging indicator. The total leakage current is the sum of the resistive component and the capacitive component. Let's proceed towards the problem statement. The previous method used resistive component of current as an aging indicator, and for effective IR, various combination steps are required. They also provide less accurate results. These steps are complex and there may be a chances of error during computation. Let's proceed towards the literature review. Previously, different methods have been used, which include least square method, conventional method, modified surface current method, and hybrid method, circuit based method, and capacitive current compensation method. But all of these methods have their own limitations. In the least square method, scientific equations are developed to extract IR and IP, and in conventional method, IR is obtained at the peak instant of the voltage. In modified circuit, the theoretical basis of modified circuit method resides on 180-degree phase shifted capacitive current injection to the measured leakage current. Let's proceed towards the methodology. First, the new method which is proposed for the online condition monitoring of surge resistor is based on the correlation method. We have taken three samples of 120 kV rated zinc oxide surge resistor. All of these three samples have the same voltage current characteristic and the total diameter. Then we calculate the phase angle formula T is equal to sine inverse of IT over IT. Then after calculation of the phase angle, then we calculate the power factor by using the formula power factor is equal to cos theta. Then by using this phase angle, the power factor, we calculate the correlation coefficient by using MATLAB software. For the validation purpose, we use modified Switzerland method approach, and for using then we use different blocks which include signal builder block, zero crossing detector, frequency detector, variable time delay, current phase shift, peak detector, and shifted peak time block, and dispensable current block. The purpose of the signal builder is to form the waveform of different amplitudes and frequencies. Then the signal builder output is linked to the zero crossing detector. The zero crossing detector detects the zero crossing in the input signal. The output of the zero crossing detector is connected to the frequency detector. The purpose of the frequency detector is to detect the frequency of the signal. It has two main parts. A counter and a divider. A counter keeps track of how many times the signal goes through a complete cycle, and the divider takes the count from the counter and divides it by the output. Then the frequency detector output is connected to the variable time delay. The time delay block is used to delay the input signal and resulting in the generation of the delayed output signal. Then the variable time delay output is connected to the current phase shift. The purpose of this block is to phase shift the current waveform. The output of the current phase shift is connected to the adder block. The adder block adds the output from the signal builder and the output of the current phase shift. Then the output of the adder block is connected to the peak detector and shifted peak time. The purpose of the peak detector is to detect the maximum peak of the signal. After using all of these blocks, the capacitive component of current is subtracted from the total leakage current, and there is the resistive component of current, which is used for the validation purpose. So these are the results. This is the graph showing the correlation between power factor and the total leakage current. The red line is representing sample 2, and it has the highest correlation coefficient value. Then the yellow line is representing sample 3, and the blue line is representing sample 1, and it has the least correlation coefficient. Now here comes the validation part. After obtaining the total leakage current signal, the modified Switzerland method is used with IRA for validation purpose. This is the graph showing the resistor current component of sample 1, 2, and 3. The resistor current component of sample 2 is more distorted with higher magnitude as compared to the other sample, and it is due to the fact that sample 2 is highly aged among all of the other samples. Then this is the correlation coefficient value for sample 1, 2, and 3. From these values, it is observed that the sample 3 has the highest correlation coefficient value, and it has the value of 0.9966. So the sample 2 is highly aged. Conclusively, if we propose to leverage the correlation method, less completion steps are required by this technique as compared to the other method, and this technique is simpler than the other. Our future work is to propose an indicator based on apparent power and validate its output with the existing method, and another goal is to overcome the inefficiencies of the implementation in electronic architecture. Thank you. Here's the validation of the resistance. Calculate the resistive component of sample 1, 2, and 3, and these are the results. Sample 2 is highly distorted, means sample 2 is highly aged. Then we calculate the correlation value and use the correlation again calculate the component of the some other So the diagram of the system in brief is that the same machine applies to effort Thank you for this presentation. Now let's move on towards our next presentation. I would like to invite Vasneet Shah from NIT University to present her thesis paper on photovoltaic and efficiency analysis to high synthesized solar cells with counter electrodes of manganese dioxide and lithium.
My name is Vasneet Shah and I am based in University Department of Information Engineering. Today I am going to present my photovoltaic and embedded analysis of dye-sensitized solar cell with counter electrode, manganese dioxide and silver doping. My presentation consists of introduction, background, introduction, otherwise structure, development, demonstration, results, conclusion. As we know, there are numerous challenges to be faced by communities such as water and food shortage, environment, poverty, terrorism, etc. Among these challenges, energy crisis is one of the major challenges. To face energy crisis, energy crisis is one of the major challenges. To face energy crisis, we must need to utilize renewable energy which exists in our surrounding in the form of heat, wind, and water. Among these renewable energy resources, sun is one of the most important source of energy. Sun spectrum consists of a broad spectrum consists of UV visible, visible, and IR. Sun provides a huge amount of energy towards our daily basis. It is according to one calculation, sun provide 1,70,000 megawatt of power to our country. It is a huge amount of energy. If we utilize this energy properly, then we can easily fulfill our energy requirements. To convert solar radiation, we need photovoltaic technology, and photovoltaic technology can be categorized into three main groups. First generation consists of silicon-based solar cell and multi-junction solar cell, and achieve highest efficiency of 46%. Second generation solar cell, also called thin film solar cell, and it consists of amorphous thin film silicon, cadmium telluride, and copper indium gallium lead. It achieves highest efficiency of 23.3%. Third generation solar cell or emerging photovoltaic technology consists of quantum dot, purified, organic, and dye-sensitized. Purified achieves highest efficiency of 25.6%. DSSC belongs to third generation solar cell, and it have many features as compared to conventional silicon-based solar cells, such as transparent and color solar panels, capability to adapt any shape and size, easy fabrication process, and work on day and night. Now we will come to the structure of DSSC. So DSSC consists of transparent conductive substrate, wide range of semiconductor oxide such as titanium dioxide, zinc oxide, or neodymium pentoxide. Dye are photosynthesizer, which are the active area of the cell, electrolyte and counter electrode. Among these components, counter electrode play a crucial role in the performance and efficiency of DSSC. Counter electrode work as a catalyst for redox electrolyte and as a positive electrode to collect electrons from the external circuit and complete the cell circuit. Different types of material used as a counter electrode material. Among these materials, platinum is most widely used due to their electrical conductivity and excellent electrophoretic activity, but we know platinum is the most expensive and rare element. So for the large-scale commercial application, platinum is not a good material. So to replace platinum, we need different types of materials such as carbon-based material, metal oxide, and conductive polymer have been used as an alternative for platinum. Manganese dioxide also used as a counter electrode material, but manganese dioxide have some limitations such as relative low catalytic activity, slower charge transfer kinetics, and lower conductivity. So in this research, we use AC-doped manganese dioxide to overcome the above limitation of manganese. Now we will come to the operation of DSSC. So the operation of DSSC is closely similar to the photosynthesis process in plants. When light falls on the dye will be excited and electrons jump from HOMO to the LOMO of the dye molecule, where the electrons enter into the conduction band of titanium dioxide, from where it enters into the external circuit. During this operation, electrolyte work as a regenerator for the excited dye, and counter electrode work as a catalyst for the electrolyte, and as a positive electrode to collect electrons from the external circuit. Now we will come to the application of DSSC. So first of all, we clean a pure substrate by advanced alipar. Then we deposit transparent TiO2 layer, which have particle size of 15 to 20 nanometers by Dr. Blade method. Then we anneal this substrate at 450 centigrade for 30 minutes. Then we deposit another type TiO2 pair which have larger particle size and use as a scattering layer to harvest maximum light. Then we again anneal for 30 minutes at 450 centigrade. Then we dip these TiO2 coated electrode into dye solution for 24 hours. Another hand, we prepare counter electrode from amino 2 and Ag2 in amino 2. For this purpose, we disperse amino 2 and Ag2 amino 2 in deionized water and deposited on F2O substrate by drop casting technique and anneal it at 60 centigrade for 5 hours. Then we assemble this photoanode and counter electrode with the help of a sealing material called metallic, which have 60 micrometer thickness. Then we inject liquid electrolyte to the hole of counter electrode and seal the hole with aluminum paste. This is the final shape of our fabricated DSSC. Now we can come to the photovoltaic characterization. So for photovoltaic characterization, we use solar simulators which have one sun illumination. From IV characteristics, we expected different photovoltaic parameters such as open circuit voltage, short circuit current density, ideality factor, maximum current and voltage, and series and shunt resistance. This is the IV curve for ideal solar cell. Now this is our obtained result for IV measurement. From figure, it is clear that Ag log amino 2 show higher short circuit current density and open circuit voltage than Heber amino 2 based DSSC. Similarly, they also show higher power density than Heber amino 2 based DSSC. These are the formulas which we use for calculation of fill factor and power conversion efficiency, and these are the photovoltaic performance parameters which we calculated by using these formulas. From this table, it is clear that Ag-doped amino 2 show higher power conversion efficiency of 3.05% than Heber amino 2, which show power conversion efficiency of 2.86%. Now we will come to the impedance spectroscopy. So impedance spectroscopy is a useful technique to characterize the interfaces and junction of electronic and photovoltaic devices which provide information about the charge transfer processes at interfaces, lifetime of photo-injected electron and diffusion length. It also used to analyze the electrical behavior such as backend potential, drop intensity, track and interface state in semiconductor devices. This is the electrochemical impedance spectra of our replicated ESSC. From figure it is clear that pair MnO2 show higher diameter of semicircle which relate to the charge transfer kinetics. It means like if we show in the it is clear from the figure that diameter of the pair MnO2 have larger than pair Ag of manganese dioxide. From this, we extracted that charge transfer resistance of manganese dioxide have larger than Ag of manganese dioxide. Similarly, body-based plot were used to calculate the electron lifetime. And from figure, we can extract the value of electron lifetime, and platinum show higher electron lifetime than silver of manganese dioxide, and silver of manganese dioxide show higher electron lifetime than heaven MnO2. Higher electron lifetime is best for solar cells. Now we will come to the capacitance frequency characteristic. So it is very useful characterization technique, particularly for solar cells, because it provides information about their charge carrier behavior, interface state, and overall electronic structure. The value of capacitance is decreased with increasing the frequency as shown in the figure. At lower frequency interface state follow the AC signal and add it excess capacitance. But at high frequencies, these interfaces unable to follow AC signal can show lower capacitance. Similarly, conductance frequency characteristics also shown in the figure. The value of conductance is also directly varies with frequency. The value of conductance increases with increasing frequency. Similarly, Ag doped MnO2 show higher conductance than pure MnO2 based ESSP. Impedance frequency characteristics. So Ag doped MnO2 show lower impedance than pure MnO2 based ESSP but higher than platinum. Impedance and frequency show an inverse relationship as shown in the figure. Conclusion: comparative study. In this research work, we have done comparative study of photovoltaic parameters and impedance spectroscopy of manganese dioxide and Ag doped manganese dioxide counter electrode based dye sensitized solar. Impedance and IV characteristics provide an insight into the photovoltaic performance of the solar cell. Ag MnO2 show better performance than J1 MnO2 due to its higher conductivity and excellent electrocatalytic activity. Thank you. हमने तो जो फोटो नोट बनाए वो डॉक्टर प्लेटिंग से बनाए हैं बाकी जो काम करें तो हमने क्राफ्ट आर्टिस्ट से बनाए सर हमारे बाकी हमने वो confidence of opportunity. I determine counter silver नहीं सिल्वर में कम नहीं करनी गणित का एक्सपेक्ट की कंडक्टिविटी कम थी तो हमने सिल्वर की डोपिंग करके उसकी कंडक्टिविटी इंक्रीज
Thank you for this presentation. Moving forward, I would like to invite Director of Consultancy based from the Farm Institute of Technology to present his paper on green synthesis of nanographite materials from diamond F1 borate steel, a sustainable approach for carbon-based materials.
Myself is Mr. Parkway. I am writing university and I'm going to present my paper concept on three systems of nanographite materials from diamond and oil steel. Our presentation will take you through a voyage of discovery, exploring how seemingly mundane fluid based can transform into remarkable material with the power to shape the future of physics. As you all know that we are evaluating environment on this and then today there's a team and this is our mistake and we come our target to make a some plan to run some electrical devices. This is very useful for us. As we believe, it is just fascinating research not only highlight the scientific achievement but also underscore the profound environmental implications and the limitless possibilities. The significance of nanographite material from limited at NGM hold immense significance in the realm of advanced materials. This material characterized by the nanographite type and structure and dimension properties owing to their unique morphology. NGM possesses several key advantages like it has high surface area, good conductive properties, and its thermal stability and mechanical strength. Let me talk about the high surface area. Nanostructuring impact an extremely high surface area. And the enhanced conductivity of graphite in future enhances the nanoscale making and we have even before application was very good electrical conductivity. Thermal stability is material exhibit remarkable thermal stability, rendering them useful in high temperature environment. Mechanical strength, despite their nanoscale dimension, and they display the impressive mechanical strength due to big graphite. Our primary objective of the research presented in the paper was to investigate feasibility of producing nanographite materials from lemon and orange peel solving using the pyrolysis method. Pyrolysis is a thermal decomposition process involved in trying to take out complex organic compounds in the fruit peel powder and transform them into the carbon-rich chemistry. Biosynthesis, another significant tool was to characterize MGM complexity by Actardi and Actardi is used to analyze the structure analyze and Fourier transform is used to their compositional analysis. The research aims to confirm the line nature of the MGM using Actardi analysis, thus validating their potential for revised application including in the field of electrical conductivity. Provide insight into the functional group, better diagrams using FTIR, analysis shading to light on their chemical composition and suitability for electrical application. The methods we will use are various crushing, final isolate, final communication, centrifuging, and grinding. In these, if we look at that, for the first step, we get the heat of oranges and lemon. This process is same for orange and lemon, so I will discuss about oranges and lemon. The same process will also performed by orange. First of all, the shredding and crushing the lemon peel and drying them sunlight. After shredding it was crushed and make some powder. After powder, we go for the pyrolysis and at 500 degrees centigrade for 3 hours. We got a dark gray powder, which is a carbon dioxide, and then we truncated with a distilled water for 10 minutes, and after truncation, we go for the centrifuge area at 800 RPM to dissolve easily. After centrifuging, we go for the grind and we go on carbon powder. After achieving this powder, we go for the characterization and we go for characterizing XRD. As we discussed, that XRD is structure and grinding technique. This graph shows the XRD of NDA. As the machine does peak, this peak was based on almost 22 degree almost. Using this graph, this is the lemon orange peak. Using this graph and this formula, we got the size of the nanomaterial. The calculator formula relates the crystalline size, which gives the size of the nanomaterial. Here the discussion is giving that V is the crystalline size, K is the pressure constant, which is 0.9, and wavelength is lambda for every use for the patient, and theta is the breaking point of the half vacuum of it, and theta is the angle of reflection. Using this formula, we got the equation and find the value of 9.8 nanometer size of nanographite material. The same formula is for the orange also, and we got size point to be almost 11.96 nanometer. Fourier transform is inspired spectroscopy. The Fourier transform spectroscopy is limited to study the conformation or functional groups on the surface of the sensor. This graph shows the combination of the carbon dots or carbon in our food powder. And this is there are too many materials also found in our product. The free mounting machine shows that it's a graphite combination, and it has other molecules also for our product. This is the orange piece, and the presence of three double bond peak indicate that the P dots are made of graphite structures. There is the OH and P double pro and PH bending peak suggests that the P dot has OH and P and surface molecules attaching on the surface. In conclusion, the combined XRD and FTR analysis has been repeated, and this shows that it has electrical conductivity, and in future we can make a circuit product for our sensor as my special purpose sensor that inshallah we go for development and adoption of the sensor by using these products. some private bus like nearby Noida, Metro station, and this is considered waste product scheme. And if we talk about annual their finance last high expenses, so to go for the और अगर मैं ओवरऑल बात करें अगर यूज प्रोडक्ट की बात करें तो मोस्ट ऑफ माय प्रोडक्ट डाउन हुई लेकिन अभी तो भी हमने कस्टमर करना पड़ा था लेकिन ये है बेस प्रोडक्ट का बनाए तो हमारे पास अभी 10 ग्राम बना था और ऑलमोस्ट वो 1000 और अब ये तो इतना जो है कि IEEC का ये मेरा तो उसमें जो मिनिमम मार्क्स है वो अलग अलग लाइक अगर ठीक है उस हिसाब से हमारे यहाँ बहुत
Thank you for this presentation. To the presenters, I would like to thank you to all the lecturers, Dr. Tariq Adnan from Delhi University and Dr. Sagar. Now I would like to call Dr. Abdul Rahman Javed, Program Chair of IEEC, to present his speech to Dr. Sagar. Now I would like to call the Tariq to speak Dr. Over to have this. I would like to invite Abu Bakr Siddiq, Sir Abu Bakr Siddiq to have the stage.
So this session is now over. Please proceed to the national movie civil law for the proceedings and closing session. Thank you very much.
Thank you very much.
सर अगर एक मिनट नोट जो प्रेजेंटेशन श्योर श्योर
आप प्लीज नाम बता ये नाम बता
I would like to invite the Minister from Delhi University